Lithography. In this step, the manufacturer takes what is called a mask, essentially a blueprint of the final chip, and uses light to imprint miniature copies of that onto the silicon wafer. This is the step that actually transfers design onto silicon, and the machines used to create it are some of humanity's most incredible feats of engineering. At the cutting edge, EUV or extreme ultraviolet lithography machines are used, and unlike in consumer marketing, extreme ultra actually feels like an understatement for what they do. The light used in these machines has wavelength so short that even the air absorbs it, so they have to work in a vacuum, and to generate that light they use an ultra high powered laser to blast tiny drops of liquid tin mid-air somewhere around 50,000 times a second to create plasma, which then creates the light that they bounce through an insane web of lenses and mirrors and onto the wafer. Dutch firm ASML is the sole producer of high-end EUV machines, and a single one of their machines weighs around 100 tons and costs around $130 million. The company only makes about 25 of them a year, of which TSMC has bought more than half this year, and they are such a sign of legitimacy that a Chinese company called Hongxin scammed their local government into giving them state subsidies because they owned a single older generation ASML machine. Like that almost on its own was enough to convince the government right before the company mortgaged the machine off without ever having used it. So yeah, much like with fabs, making high-end equipment for the industry is so complex and so expensive that there are just not a lot of players left on the high end. And in some areas, like for example lithography, there is essentially a monopoly. And this, as you might have guessed, is bottleneck number 3 in the industry. And as EUV relies on a lot of US tech, this is the bottleneck that the Trump administration actually used to force non-US companies like TSMC to stop making chips for Huawei. If they didn't drop their Huawei business, the US could cut them off of things like EUV, and that would be game over for a high-end fab. And the last domain in semiconductors is often called packaging and testing. And this is where the silicon wafer gets cut up into individual chips, wires and connectors get attached, the chips are put into protective housing and then finally tested for quality before being sold. And to put it bluntly, this domain is much less high-tech and much less consequential than the others. It is typically outsourced to hundreds of different companies, so just know that it exists and I will spare you a deep dive on it. So that's your overview of how the chip industry works, and over the last couple of years of obsessing over this topic, there's a couple of main realizations that I've had. First, almost all of the incredible diversity and competition in the industry comes from the design phase, while the rest of the industry is going through massive consolidation, which leads to the entire